This is the configuration for breaker number 1. For breaker number 2, we are going to do the same. And the black one is coming from the other face. And here we are going to do the same protocol, and we are going to bring the red one from the other side. And what about the other one? The other one depends of this.
Neutral.
This phase. This is phase 1, and this is phase 2. The neutral, you have a neutral bus bar here, in the middle one. In the single breakers, you only have the phase. The neutral goes directly to the equipment. The neutral is not interrupted in the breaker. If you have a panel, Fausto, you have single breakers. With that single breaker, you interrupt only the hot. The neutral is coming from a common neutral bus bar. That one is coming here. Yeah, of course, it's coming from the neutral. It's coming from the neutral. It's coming from the neutral. It's neutral. And this ground is coming from the original ground, and coming from the ground of the generator, because the generator produces your own ground here, and that ground enter here. And this element produces your own ground here. In this point, both of them are connected together, and after that goes and enter here. Everybody follow me? All of those connections of the ground should be before the galvanic isolator. Where is located normally the galvanic isolator in a boat? Okay, it's pretty close to this one. Inside of the boat, you check in the wall, in the engine room. Oh yeah, this is the outlet. Let me okay, it's here. It's pretty close. It's pretty close to the outlet. It's separated 2 feet, 3 feet maximum. Be careful, because in some boats, some manufacturers, they create after this outlet, in between the outlet and the switch selector, they install other main breakers for safety. And it's very common. You say, I don't know what happened. I have power in the short power cable. It's great. The short power cable entered in the boat, but I don't have power in the boat. If you follow, the outlet is hiding another breaker. Okay, good. This is the configuration. We are going to connect exactly the same like we did in DC. We are going to connect the voltmeter, volts. How you read volts, my friends? In parallel. You connect hot with hot, neutral with neutral. When you have the multimeter, you select volts, AC, with the symbol, the sinus, and normally the black one is in the small terminal in the hot, and the red one in the neutral. But you can connect opposite, no problem. All right, for AC. Right? Okay. In that case, I want to see the voltage in the voltmeter in the phase 1. All right, the voltmeter in the first one is connected.
Phase 1 hot and neutral.
And the other one?
Neutral.
Enter here in the neutral. Ready? The second one.
Same thing.
Voltage enter here, and neutral through the neutral. Good? To the neutral bus bar. All right. You remember how you read frequency with this? Quickly? You remember? All right. I select my voltmeter in volts, AC. Volts, AC. I introduce the terminal here in the multimeter. How much is the voltage?
12.3.
122, and now?
Hit the yellow button and gives you frequency.
Frequency?
60.
60. I change the position of the terminals to read the frequency.
No, same.
It's basically the same. No? I return to voltage or frequency. What is the meaning of that? The voltmeter and the frequency meter are in parallel, because it's the same. Okay, how I wire my frequency meter here? I am going to do a loop. I am going to connect is in parallel. All right. You remember how we connect the AND meter in DC?
With a shunt.
Okay, but basically you interrupt the positive and you insert the AND meter over there. You put the shunt for protection. But really, you cut it and you read amps, where you can read the consumption in amps of one specific device, in the breaker for that device, because the breaker interrupts the positive cable, no? In that point, I can use my AND meter. You remember that I mentioned that in DC, there are AND meters clamp, but the clamp is not accurate. Why? Because the signal, this one is a magnet, no? Positive and negative, you see? Negative and positive. When you pass a signal DC, the signal is straight. And depending on the insulation of the cable, the reading here is erratic. In AC, no. If I have a clamp and I pass through the hot line, how is the shape of the wave? Beam, 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 beam. When the signal touch, you read amps. You read the flow easily. In AC, the best tool to read amps is the clamp. Is the clamp. The clamp. Mr. Lopez, to install the AND meter in the AC panel, I need a clamp. Okay, no, I am going to install one permanent clamp through the hot line. This is the donut. I am going to install one donut here in the hot line and other donut here in the other hot line. And those cables
go
to the gauge. Internally, the donut is a magnet with a coil. Okay. This donut is for this gauge that is 30 amps. This is 30 amps. The other gauge have another donut. The donut is brother of the gauge.
Yeah.
When you buy the gauge, AC amps, the gauge is coming with your own donut. Look at this. This is the donut. This is the donut for this gauge. You see the donut? This is the donut for other gauge, big one, more capacity. It's clear? The donut is the clamp. It's the clamp. In the pedestals, you have donuts individual per phase. Look, donut per phase 1, phase 2, and phase 3. And this equipment, this computer, is located here, is connected with the watt meter. The manager of the marina, at the end of the day, taking the picture of the consumption of this boat, this, for the bill. At the end of the project, you call the manager of the marina, hey, my friend, can you prepare my bill because I leave today? And they, according with those readings, day per day, they calculate your consumption in amps in that pedestal, and you pay. Because with this consumption in amps and the voltage, you have the power. Power is voltage times intensity.
Yeah.
Simple. Okay, all right. We are going to install. And here I am going to locate my donut, and my donut have two. All right, and I am going to connect. The other donut is here, no? And the cable goes here and here from the donut. Two donuts, one per each phase. And this is the AND meter. This is the hertz. This is the voltage. Pam, 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 pam.